So essentially, you discretize the steps and make it go towards 0. That's the whole idea. So this is how you draw. Essentially, it's using the idea of continuity, IVT, intermediate value theorem. Okay. So this is for you the wavy curve method. Okay.
Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT MS, ISI MStat, and CMI MSc Data Science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses.
What if A1 equal to A2? Like there are multiple similar roots. There are multiple same roots. Like what if there is a x minus 1, x minus 2, x minus 1, x minus 1, again x minus 2, x minus 2, x minus 3. What if in this case? How will you draw this? So there is 1, there is 2, there is 3. So but there is x minus 1 whole cube, x minus 2 whole square, and x minus 3. The idea is very simple. The idea lies in convergence of functions, like you will see now. So basic idea is this, that draw the function. So there are three roots, right? So draw the functions at, let's assume that they're not similar roots. Let's draw it at epsilon 1. Now 1 minus epsilon and 1 plus epsilon. Here there are two 2's, so let's draw it at 2 and 2 plus epsilon, and at 3 there is 1, right? Now let's draw the function. So here it's positive, here it's negative, so you can see it's positive, and here it's positive, so it's positive, negative, it's coming down, and it's alternating. It's like a wave, it goes up, right? This is a graph. Now what you do is that you tend this epsilon towards 0. So what will happen? Let's draw it here only. If you tend this epsilon towards 0, that means this will go towards this and this will go towards this. So what will happen? Observe that this parts will become 0, right? This parts will club together, and here this plus will go to 0, right? So if you draw, observe that this part will be clubbing together, so it will be like, it will coming like this, okay, and this part is not there, so it will be this region, and then this region, and then this region, right? So therefore it will look like this. It will go down like this, and it will, so this part, the blue region, will come down, and here it will be like this. It will be kissing this point, and then it will go like this. We will find out the graph by tending epsilon towards 0. So whenever there are multiple ones, let's say there are 5 ones, we will be spacing equally, let's say, points around, so that we understand what is the case if they are discrete points, and then we will tend the epsilon towards 0. So when it tends towards 0, observe that which portion will disappear. The brown portions will disappear, right? That means which portions will stay. This portion will stay. Since brown portion will disappear, this portion will not be there. Then it will start again with this portion. It will go till this portion, then the upper portion will not be there, the above portion. Then it will start again from here. Now how will you represent this now? By drawing. This, so it's coming down like this, and there is no such thing, and then this blue thing again starts, so it's like this, and again here this goes here like this, but this again blue thing starts, so it's joins like this, and then it So it's like wherever the portions are, wherever the which portions are disappearing. Okay, so let's try out. So this is the basic idea of how to do multiple roots. Now let's try out Desmos. Okay, so let's say x minus 1 minus 2 x minus 3. Okay, now let's do it the same case, x minus, let's say, so 1 minus epsilon, so it's minus 1 plus, let's say, a. Add a slider for a, that's a different thing. Then x minus 1, then x plus, then x minus 2, x minus 2 minus a. Am I doing it correctly? Let me check. So if this is this, so x minus 1 minus epsilon, x minus 1, x minus 1 plus epsilon, yeah, x minus 2, x minus 2 plus epsilon, x minus 3, that is x minus 1 plus epsilon, x minus 1, x minus 1 minus epsilon, x minus 2, x minus 2 minus epsilon, and x minus 3. So in forms of epsilon I have written 3, a, sorry, and x minus 3, and epsilon should go from 0 to, let's say, 0 0.1, step is 0.001. Okay, let's say it goes to 0.5. Okay, great, super. So now series diagram. Okay, the red curve is the curve of the, and see that's how it looks like, the the blue curve. Okay, I think I did some mistake. Did I do it correctly? Oh, it will be x minus whole to the power 3, x minus whole to the power 2. Yes, yeah. So okay, so you see how it looks similar to this what we have done, but yeah, let's understand this very carefully. So as we move, yeah, so this is the maximum. Let's make it a big, let's say, yeah. So here is the curve when the epsilon is 0. That means it has 1 minus 0, like 0.21, 1.82, and then at 2.8, and then 3. Okay, you can see it's wavy, right? Now as we tends towards 0, it see how this two parts, observe that how this two parts, this, the region between 1.8 and 1 and 1.8 and 0 point, like 1 minus epsilon and 1 plus epsilon and 1, this goes to 0, hence they merge towards that blue, and hence the negative part, like essentially it becomes continuous at this portion. Do you understand? It merges with this curve, and exactly if you see the graph now, it looks exactly the same, that now see the blue curve, it goes down, exactly not the same, like the curvature and things are not same, but it goes down. Let's see, it goes down and touches this point and again goes at 3. So observe, this goes down, touches at 2, and then goes up at 3, and from below. The issue is that for the cone is that you cannot use this for polynomials which do not have real roots. You have to rely on the next methods.
To book a trial class for your preparation courses of IIT MS, ISI MStat, and CMI MSat Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Stay tuned and stay blessed.